Even if you don't think you're right, it doesn't matter to me. I just want to see that we're taking a guess. So I want to see what's going through your brain. Okay, thank you to those who are responding. Excellent. Good job. Good. Every one of you said 3/4. Beautiful. And someone even said because you can't add the denominators. Good. These are common denominators because they are the same. So when you're adding fractions with common denominators, Isabella, I would stay on if you could, okay, at least for this. Since these are common denominators, we keep the common denominator. Again, since they're common denominators, we can add the numerators or the top numbers. 1 plus 2 is 3. All right, here's another quick one. 2/5 plus 1/5. Go ahead, tell me. What do you think it is? Write it in the chat for me, please. Thank you, Oscar. Thank you. Good job, Mari. Good. Like some more people to put some ideas down in the chat. Remember, it doesn't have to be right. You just have to give me something. Good. We have a common denominator, so we keep that the same. 2 plus 1 is 3. 3/5. Excellent. All right. We seem like we're pros at this. So let's level up here. What happens if we have 1/3 plus 1/2? Here's my question. Is this the answer? Oh, okay, 1 plus 1 is 2, and 3 plus 2, that's 5. Is that my answer? Is this correct? All right, Isabella's saying no. What do we think? Well, Isabella, I agree with you. This is not correct. Absolutely not. We can only add fractions if they have the same denominator. The problem is we don't always get questions that have the same denominator. So what we need to do is create a common denominator. Would you look at that? So here's how we do this. Are you ready? All attention on your screen, please. Here's what I do. I make 2 boxes. I am going to skip count or find the multiples of each of these denominators. So 3. 3 times 2 is 6. 3 times 3 is 9. Okay. 3 times 4 is 12. Here, 2. 2 times 2 is 4. 2 times 3 is 6. 8. My question for you is, if we are looking for a common denominator, we're looking for the number that they have in common. What number do both of these have in common? Please write that in the chat for me. What numbers do these both have in common? And so what I mean by in common, it means they have to have the same number. So what number do you see in this box and in this box? There is one number that they have in common. Good. Amari, good job. Luke, good job. Isabella, yes. 6. Do you agree that both of these boxes have 6? Okay. That is step 1. Okay. Step 2. We now have to turn 1/3 and 1/2 into fractions with a common denominator of 6. We're going to create equivalent fractions. I will explain what equivalent fractions are in 1 second, but just watch. So 3 times what equals 6? Let's check. 3 times 1, 3 times 2. Okay. So I'm going to do 3 times 2 equals 6. Well, what I do to the bottom, I have to do to the, what do you think? What I do to the bottom, I must do to the, write it in the chat. Good job, Annalise. Good job, Luke. Times 2. What I do to the bottom, I do to the top. 1 times 2 is 2. Excellent. Now over here. Good job, Mari. 2 times what equals 6? Well, 2 times 1, 2 times 2, 2 times 3. What I do to the bottom, I must do to the top. 1 times 3 is 3. All right. So I have these 2 new fractions. But they are equivalent. I didn't change the problem. I'm still solving for the same thing. It's just represented differently. Let me prove to you why this is still the same problem. I'm claiming that 1/3 is the same as 2/6. So here's my circle. I'm going to break it into thirds. I need one of them. Okay. Here's my circle. I'm going to break it up into sixths. I need 2 of them. My question for you is, did I shade the same amount of each circle? Are these circles equivalent? Did I shade the same amount in each circle?
Yes.
Yes. Excellent. Thank you. All right. So that means that they are equivalent. Right? And if you don't believe me,
What about they're odd?
say that one more time.
What about if it's even against an odd?
Even against an odd. What do you mean by
like 1/3? Make it into something 7.
We're looking for common denominators, though, Luke. So they have to be the
It's
same
not a common
number.
denominator. Oh, okay then.
Okay.
Right?
Well, 8. 3 to 8.
So, hold on one second, Luke. I will answer that question. Let me just finish this problem, and then I will work with you, okay? So I'm trying to claim that 1/2 is the same as 3/6. Some of you may already see that. That's okay. Like, here's 1/2. Then here are my sixths. And I need to color in 3 of them. Have I again circled or colored in the same amount of each circle? Awesome. Thank you, Isabella. I appreciate it. Thank you, Annalise. Great. So right now I've just proved to you, yep, these are the same fractions. They just look different. They are equivalent. In fact, if you were to take 2/6 and simplify it, you would get 1/3. But we'll get there. Here's our last step. Instead of 1/3, I'm going to write 2/6. Plus sign, plus sign. Instead of 1/2, I'm going to write 3/6. Hey, do we have a common denominator now? Yes, we do. Good job, people. Which means I'm going to keep this the same, and I can just add the top like normal. 5/6. Excellent. Remember to add. Yep. Good job. So, on a scale, 1 to 3, where 1 is no, this one is and this one is woohoo. How are we feeling?
Woohoo!
About the subject?
What?
About the subject?
About what we just did right here, about how to find a common denominator.
Woo!
Excellent. Good. We have nope. You can't read that. Let me try to write it in black. So these are our options. We are either a nope, an or a woohoo. All right. Let me know in the chat how we're feeling. Okay, waiting for responses from Amari, Annalise, Dario, Darielis, Dustin, Hennessy's, and Oscar. Awesome. Thank you. All right. We're feeling pretty confident, Mr. Wetmore.
It sounds like it.
Pretty confident. So, our other classmates are going to be joining us in 3